The universe is vast. It's filled with galaxies, stars, and planets beyond our wildest imaginations. We yearn to explore these distant realms, but a cosmic speed limit stands in our way. It's the speed of light, a barrier that seems insurmountable. Light travels at an incredible 186,282 miles per second. That's fast enough to circle the Earth over 7 times in a single second. Nothing in our current understanding of physics can exceed this speed. Einstein's theory of special relativity tells us that as an object approaches the speed of light, its mass increases infinitely. To break this cosmic speed limit, we need to think outside the box. We need to challenge the very foundations of our understanding of space and time. What if we could fold space-time, creating shortcuts through the cosmos? What if we could travel through wormholes, theoretical tunnels connecting distant points in space-time? These ideas may seem like science fiction, but they are at the forefront of theoretical physics. They represent our ambition to push beyond the boundaries of the known. The quest to explore the universe is a journey into the unknown. It's a journey that forces us to question what we think we know. The speed of light is not just the speed of photons, it's a fundamental constant that governs the very fabric of the universe. Einstein's theory of special relativity, published in 1905, revolutionized our understanding of space and time. It showed that these two entities are not absolute. Instead, they are intertwined and relative to the observer's frame of reference. Einstein's theory rests on 2 postulates. First, the laws of physics are the same for all observers in uniform motion. Second, the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source. These postulates have profound implications. They suggest that time is not a universal metronome, ticking at a constant rate for everyone. Imagine 2 observers, one standing still and another traveling at a significant fraction of the speed of light. Time will pass differently for these 2 individuals. The observer in motion will experience time dilation, meaning time will slow down for them relative to the stationary observer. This concept is not just a theoretical curiosity, it has been experimentally verified. Time dilation is a mind-bending consequence of special relativity. It means that time is not an absolute, but a relative quantity. It depends on the observer's motion. As an object's speed increases, time slows down for that object relative to a stationary observer. Consider a thought experiment involving a pair of twins. One twin stays on Earth while the other embarks on a high-speed cosmic journey. Upon the travelling twins' return, they would be younger than their Earth-bound sibling. This is because time would have passed slower for the travelling twin due to their high velocity. The faster an object moves, the more pronounced the time dilation effect becomes. If an object could reach the speed of light, time would theoretically stop for that object altogether. This highlights the profound implications of special relativity for our understanding of time. Faster than light travel opens a Pandora's box of paradoxical possibilities. If we could surpass the speed of light, we could potentially travel backward in time. This concept arises from the idea that exceeding the speed of light would mean overtaking the flow of time itself. Imagine traveling to a distant star system at superluminal speed, then returning to Earth at the same speed. You could potentially arrive back on Earth before you even left. This scenario creates a temporal paradox, as it violates the principle of causality, where an event cannot precede its cause. The idea of time travel is tantalizing, but it raises profound questions about the nature of time and our place in the universe. If we could change the past, would we cease to exist? Could we create alternate timelines? These questions delve into the realm of metaphysics as much as physics. One of the most famous thought experiments related to time travel is the grandfather paradox. This paradox encapsulates the potential for causal inconsistencies arising from backward time travel. Imagine a scenario where you travel back in time and accidentally kill your own grandfather before he met your grandmother. This action would create a paradox. If your grandfather died before conceiving your parent, you would never have been born. But if you were never born, you couldn't have traveled back in time to kill your grandfather in the first place. This paradox highlights the inherent contradictions that arise when we consider the possibility of altering the past. The grandfather paradox forces us to confront the fundamental question of whether the past is immutable or whether it can be changed. It challenges our intuitive understanding of cause and effect, suggesting that the arrow of time may not be as straightforward as we perceive it to be. The quest to understand faster-than-light travel and its implications on time is a journey into the uncharted territories of physics and metaphysics. It forces us to confront the limits of our current understanding of the universe and to grapple with concepts that challenge our intuitive grasp of reality. While the idea of time travel remains largely in the realm of science fiction, the theoretical principles that underpin it are grounded in the laws of physics. Einstein's theory of special relativity, with its concepts of time dilation and the relativity of time, provides a framework for understanding how time is not an absolute, but a malleable entity that can be influenced by motion. The paradoxes that arise from the possibility of faster-than-light travel serve as reminders of the intricate and often counterintuitive nature of space and time. They highlight the importance of continuing to explore the boundaries of our knowledge, seeking answers to questions that may seem unanswerable. The universe is full of mysteries, and the pursuit of understanding these mysteries is what drives scientific progress and expands the horizons of human knowledge.